Phison's back, and this time with the Gen 5 high-performance, low-cost NVMe SSD, M.2. Let's take a look, because this thing's available in 1, 2, 4, and 8 terabyte capacities. It performs well, but there's some things you should know because it's DRAM-less. But that's not a dirty word. Not exactly. Let's chat. As you may know or may not know, Phison makes controllers, and a lot of people incorporate those into their products. Controllers for controlling NAND memory. And there's some really exciting things going on in NAND memory right now, mainly the fact that PCIe interfaces are so fast that it is driving the acceleration of flash media that can be signaled faster. And what that means is that the PCIe interface and the controller are so fast, the thing that's slow now is the actual DRAM. And the manufacturing process for this is really super interesting. Like, the actual flash cells, the flash storage wafers, haven't changed dramatically since the inception of flash, but then there's another wafer that comes along and might get glued on top of it, or you might have more layers that are added for the actual controller, and that gets better at differentiating the different levels of cells inside the controller, blah, 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 faster. Like, there's a lot of computation that has to happen on the controller on the M.2 in order to turn flash memory into a usable storage device that works like we expect them to in modern desktop computers. In fact, in the enterprise, it's gotten so crazy that you can actually run microservices on the controller for some really high-end storage systems because you want it to go that fast, you need that level of redundancy, or you want to fine-grain control the transactions. You're going to pierce the veil of all of those layers of abstractions and actually run microservices on the actual disk controller. But that's not why we're here today. We're here to talk about a 6-watt E31T. Now, this is not a replacement for Phison's other higher-end PCIe controllers. The E26 is still the fastest, or one of the fastest, PCIe Gen 5 controllers that manufacturers find use for in their M.2. No, this is aimed more about power efficiency. This thing tops out at 6.1 watts, which is fantastic. That makes it a good candidate for notebooks. It is PCIe Gen 5, and Gen 5 is generally not a great candidate for notebooks, but it can run in 2 lanes of PCIe Gen 5. That seems to be the strategy moving forward for next generation laptops. We also see that in enterprise. So we see like the E1 form factor going down to 2 lanes because, we just need bulk storage, and that gives you 8 gigabytes per second with just the 2 lanes. And this drive tops out at about 10 gigabytes per second sequentials, but the random performance is also pretty good too. Let's take a look at our storage benchmarks. The storage benchmarks for 3D Mark actually look pretty good. This is a DRAM-less controller, which means that it's less expensive to manufacture because it doesn't require DRAM. It's a popular misconception that DRAM is used as a kind of cache or buffer or something like that. Really, the DRAM is used for storing in-flight information about what's going on with stuff that is stored on the flash. So it's more for the flash drive to keep up and use its own metadata as opposed to worrying about what the user is doing with it, doing with the files, doing with the transfers and things like that. Having DRAM does mean that the device itself will be faster, but that is because the controller doesn't have to wait on the flash to return information or to store things. It's able to do that in DRAM. Not the user data, but the structure of things going on the flash memory, because it takes a long time to erase flash memory. And so when you update a sector, it actually just creates a copy of that sector somewhere else and says, okay, now this is sector 741. Sector 741 a moment ago is now invalid. And if it loses power or you reboot or whatever, it has to have some way of looking at what it was doing before it lost power to figure out which sector 741 is the real sector 741. Gross oversimplification, but basically that's what's happening under the hood. And the flash media and the software on the controller is laid out here so that you don't need DRAM in order to do that. Using a combination of host memory and special flash structures stored on the flash cells on the drive, you don't really have to do that. And so that actually works out really well here for reducing power. This is not as fast as the E26, but this is going to use less power and is more accessible and would make a perfectly reasonable games drive. It's also a good drive for your like PS4, PS5. You can just install the M.2. Phison's made sure that it works for those sort of game console use cases. The controller itself is a 7nm lithography process. So the E31T can run really well. It works great in notebooks like the MSI Raider series. It was sort of difficult to find a lot of notebooks out there. Like, it's pretty much relegated to only the high-end enthusiast gamer notebooks with Gen 5, which is interesting. The write speed on this drive is also pretty impressive. It's up to 8.3 gigabytes per second. That's best case scenario. As you can see from our storage benchmark, real world, it's a little more conservative. It's a little more modest. I suppose if you're dumping 500 gigabyte or 1 terabyte memory cards to this drive all day long, you probably want a higher end drive. But for game storage or even productivity type workloads as a boot drive, it works really well. And I'm surprised that I would say that, because DRAM-less, usually it's like spend the extra $10, spend the extra $20, spend the extra $50 and get a better M.2 for your boot drive. That advice still holds, but if you can get a good deal on like the 2 terabyte version of this, would I rather, if it's a choice between 1 terabyte and 2 terabytes, but 2 terabytes of DRAM-less, I would probably, it would be a tough choice, because I like that 2 terabyte boot volume, and the performance here is reasonable for a boot volume. It's great for a bulk storage drive, games drive, media, that sort of thing. Well, you wouldn't even, like, you could put media on a potato class thing. This is really good for games and project files and things like that, where you're not doing a lot of writing. So for my setup here, I tried a Sapphire Rapids Refresh workstation and a Threadripper workstation using both Windows and Linux. It doesn't require a special driver. The performance of Windows is oddly a little bit better than Linux. That may be down to driver tuning, or it may be down to more conservative things happen in Linux because of the DRAM-less nature of the controller. The performance is pretty close, though, between the two. It seems like the AMD platform performed a little bit better than the Intel platform, but just a hair, not a lot. And also the performance was a little different on 13th gen Intel desktop versus Sapphire Rapids Refresh, with Sapphire Rapids Refresh outperforming Intel desktop. Which makes sense, because the 13th gen CPU doesn't have that many Gen 5 lanes. So, okay, that makes sense. But it was just a quickie video to introduce you to the E31T from Phison. It's a pretty solid little NVMe. I was surprised. It was as good as it is, considering it's DRAM-less, and it's priced aggressively. So that should cascade to aggressively priced M.2 designs in the market. Here's hoping. And Windowless Level 1, I'm signing out. You can find me in the Level 1 forums.